This is your guide to power cords and how to get the right one for the job, whatever your job might be. It should be said that I am not a professional electrician, and all the facts and information that have been compiled in this video are from other professionals and other resources out there on the internet. I wanted to put this video together so that you, dear viewer, would have a beginner's guide to better understand how electricity works, how power cords work, and what you should look for when buying a power cord. So in this video, we're going to cover gauge, amperage, how to avoid electrical fires, as well as important weatherproofing and visibility tips that should be included on your cord. And then we'll wrap it all up talking about how to properly coil your power cord so that you don't damage it. And for all of my demonstrations, I will be using Flexzilla's 25-foot 3-wire 12-gauge power cord. Not only is this a great cord, but it is a personal favorite. All right, let's get into it. What is gauge and why does it matter? Gauge, also referred to as American wire gauge, AWG, is the measurement of a wiring's thickness inside the cord. Sometimes you'll also see it as just GA on the packaging. Now here's where the mental gymnastics comes in. The number is inverse from the thickness of the wiring inside the cord. So, an example, 16-gauge wire is actually quite thin, whereas an 8-gauge wire is quite thick. So whenever you go out and you're looking for a power cord, you'll often see that an 8-gauge wire is very expensive compared to a 16-gauge. So why is gauge important? Well, with a lower gauge, thicker wire, you're able to get more power to the appliances that need it to run. The only downside to this is that the cost increases with the thicker gauge. Now say you don't care about all of that, you just want to get a thinner gauge because it's cheaper and a cord is a cord. Okay, fair enough, but if you do that, you run the risk of starting an electrical fire. See, if you don't do your math, you can get an electrical fire because the device is drawing more power than the cord can safely carry. This results in the connection point between the device and the cord overheating and eventually starting a fire. Which leads to my next important point, making sure that you get a power cord that can handle the amperage that your device needs. This one says right here 15A. 15 amps is what it can handle. But how do you calculate amps? Well, devices typically say how many watts they need. So you take the watts the device needs and divide it by the volts available, which in America at least is 120, typically. So let's take an example. That bench grinder over there says that it needs 250 watts. So you take 250 and you divide it by 120 volts, which is available. And you're going to get a little over 2 amps. So, because this cord can do up to 15 amps, it's more than enough. Plenty powerful to power that bench grinder. And then there's cord length to factor in. It might be easy just to get a big cord, long one, and say, that's it, I'm good. But there's a problem to consider. The longer the cord, the more power drop-off you're going to be dealing with. So, to counter the drop-off in power, you want to get a step lower in gauge. This will allow more power to be carried all the way through to the end of it where the device is. Okay, let's do a quick recap. Lots of stuff that we talked about. First, gauge. Lower the number in gauge, the thicker the wiring, which means the greater power capacity that cord's gonna have. 2, amperage. Make sure that you've got the right amp capacity in your power cord to get the proper power to your device. 3, length of the cord. Make sure that you're getting a length that is actually the length you need, and if you have to go over 100 feet, take a step down in gauge. Now it's time we talked about safety features. The Flexzilla is a great example because it is bright green, it's easy to see in the dark, you're less likely to trip on it, and it even has a glow-in-the-dark strip along the entire jacket. Very cool. And what's becoming more common with cords is that the ends glow when there's power running through it. Last bit of advice that I'd give you about buying a power cord is to make sure you get one that can handle the environmental conditions that you expect to be working in. Are you going to be outdoors? In the rain? Is it going to be cold? Really hot? Make sure you get a cord that can handle that. This one, for example, can go all the way down to -58 Fahrenheit and all the way up to 140 degrees Fahrenheit. For the rest of the world, that's the equivalent of -48 degrees Celsius all the way up to 60 degrees Celsius. All right, so now we're gonna demonstrate how to properly coil a cord with the over-under method and the over-over method. I should say that when it comes to coiling a cord, it also matters a lot which way you have the cord facing in your hand. That's just going to determine whether it's over or under. Let's get to it. All right, so you start with the cord in your hand, and then the next thing you do is you want to go down the cord about 2 feet, and you're going to try to feel which way the cord wants to go. So the under method is where you bring the cord behind your hand here, and then you'd move your hand and put it in. The over method is where you bring the cord in front of your hand and you place it here, adding into where your hand's holding. So we'll go down the cord 2 feet. We're gonna feel which way the cord wants to go. So I'm feeling a bit of tension when I turn out this way, so we wanna turn it this way and see, yep, there, it just falls right into place. Now down here, which way does it wanna go? Ah, there it is. Goes right in front. Go down the cord a little more. A little too much tension going this way, so we're gonna try the other way. Yep, falls in place. Now, see this one, I'm getting more of that resistance this way. It doesn't wanna go over, so we're gonna go under, tuck it underneath, and bring it up behind. And finally, over. Now the risk in coiling it incorrectly is that you will damage the wiring inside, and then you'll have to go and get a new one. And keep in mind, if the cord is plugged in on either end to an outlet or another cord, the tension won't be able to escape, so make sure it's unplugged on both ends. Now, once you've coiled your beautiful new cord, it might be tempting to take the ends, wrap them around, and tie a knot with them. But I wouldn't do that, because depending on the gauge you're working with, you might break the wiring inside. So rather than doing that, go ahead and get a 2-foot piece of twine or a rope, or a rubber strap if it came with it, loop it underneath the cord, and tie a nice little knot like that. And there you go. Not gonna uncoil, and it keeps your nice new premium cord snug as a bug in a rug. And until next time, stay safe and take care.